Well, hello, everyone. Thanks for joining in, and we hope we'll have a great session. We'll just wait for another like 5 minutes and see, and allow people to join in, and then we will get started. Till then, just wait and watch. Hello once again, and for people who have just joined in, we'll start in another couple of minutes. We'll give another 2 minutes for people to join us. Thank you for waiting. Okay, all right. So welcome everyone who have joined us. It's great to have you guys. My name is Ashutosh and I am a developer relations. I'm part of the developer relations team here at R3. I'm joined by Peter Lee, who will be there in the chat to help you guys with any questions that you might have. So feel free to use Q&A or even the chat window. It's great to have you people. I see a lot of people joining from like all over the world. We have people from Dubai, London, Sydney, Switzerland, Singapore, even Morocco. Yeah, that's great. All right, cool. So what we'll be doing today is it's a hands-on session. So we'll be doing some coding. We'll write some real code, try and develop a CorDapp, and then we'll try to run that in a demo network or like a bootstrap network, which is generally used by developers. and then we'll see how it goes, right? All right, so before we directly get into the coding part, let's just have a bit of a recap. So generally the way we do it is we have a session which more focused on the introduction part, which was done earlier in the last month. And then this is more on the hands-on part. So, but do not worry if you haven't joined that. I'll still go through a bit of a recap for the for like the first 10 minutes, and then we'll get started. And I'll also talk about things as we do the coding part as well. All right, so before we get started, here are some of the references which you might be interested in. We have a YouTube channel, which is Corda Blockchain. So a lot of useful videos which you might be interested in. There's a free training at training.corda.net. We have a public Slack. So that's a community of over 10K developers. If you're not a part of it already, so I would highly suggest you to join that and interact with fellow developers. Documentation available at docs.corda.net. Well, Corda is open source, so you can access the code repository at github/corda. If you want to reach out to us, the developer relations team, the email address is devel@r3.com. And if you are a Twitter guy, you like to tweet, so do use our hashtags, #Corda and #3, and the tags that are basically the handles that you would use for us is Corda blockchain or inside R3. All right, so that's pretty much of the work that we had to do. Now we can get into the content for this session today. So if you have any questions, just put it on the chat. I or even Peter will look at that from time to time, or you can also use the Q&A session, or Q&A, basically the tab. All right, so what we are going to do is we'll understand what we're going to build. So since we are going to build a CorDapp, so what exactly is a CorDapp, first of all? So basically a CorDapp is, okay, I see someone having a issue with the sound or the volume. Is it for anyone else? Am I audible properly? All right, so maybe something with him. All right. So we can continue then. All right, so since we're going to develop a CorDapp, so we need to understand what exactly is a CorDapp, right? So you're here for Corda. So Corda is basically the platform. It does nothing by its own. So you have to write something and deploy it on the platform for it to really do great things. Right. So what do you write? The application that you write is called a CorDapp, which is basically just a short form of Corda distributed application. Right. So CorDapp, writing a CorDapp requires you to build different modules, and all these modules will have different sort of code that you would write. So majorly what you would write for any basic CorDapp is your state, contract, and your flow. So what exactly is the state? It's basically anything that you want to put on the Corda ledger, right? So it may be a house, may be like a vehicle, a piece of land, or like just some coin, some basically token that you write. So all of these, which you basically will store within your Corda blockchain or the Corda ledger, is referred to as state. So these are the things which get stored, it gets consumed, it gets upgraded, and we'll see how that happens going forward. So that's your state. It's basically the asset. And then you have the contract, which is basically more or less the rules that you write, which will govern your state. So anytime you want to change anything in your state, you just don't do random changes. You have to go through a certain set of rules, and you have to make sure that all the rules that you have written as part of the contract are valid when you're trying to make that change, right? So that's where your contract goes in. It can be thought of as things like your business rules that you write for any particular application. And then the final piece that you want to put in is your flow, right? So flow is another very powerful feature of Corda. It allows you to write business processes or business workflows that you have. Any business that you would have different kind of business processes, right? So these are like different steps that you need to follow in a sequential manner. You mimic those with the help of the flow framework, basically. So what you would see is you have certain steps that you want to follow in a particular business process, and those are written as part of the flow framework or the flow code that you would write. And finally, when that flow happens, you would say that a particular transaction has actually occurred. So these are the three parts which come together and build your CorDapp. All right. So looking at the transaction a little bit in a more detailed fashion, any transaction is more or less will have something like an input and an output. So we talked about states, right? States are immutable. So whenever you create a state and you put it on the ledger, it becomes immutable. You can't really change that state anymore. That's basically the nature of blockchains, right? You put anything on the ledger, it becomes immutable. So what we do as part of transaction is we pull out a state from the ledger which was previously created, and then we mark that as an input to the transaction, and then we basically calculate the output. So if you want to change some property on the state, you don't really change what is already there. You just create a new one, and it's a copy of the previous one, other than the fact that it would have the changes that you would want to make on the previous state. So basically that becomes your output. So take the input, use it as an input. You take the state that's already there, use it as an input, then you create a new one with the changes, and that becomes your output. And then you take this transaction, you run that through all the contracts that you have written, all the rules that you have written. And if all the rules are valid, you see that your transaction is satisfying the contract rules, then you say that, well, it's all fine, and you can finally record it onto the ledger. Now, all these things, all these steps that I talked about, picking the input, the output, and then obviously the contract rules, it's not basically being done at a single organization level, right? So transactions require multiple nodes to interact with each other. So this transaction has to be exchanged between different nodes. So all these exchange of information, and then recording things on the ledger, running the contract rules, and all these steps that I talked about will be part of your flow. So all these will be written as part of the flow, and then once you want to run this particular transaction, you just trigger that flow, and all these steps will be taken care of. So that's how your transaction work. Again, looking at the flow at a very high level. So as I said, flows are just like steps that you would follow for a particular process to happen, right? This is taking an example of a very high level sort of or a simple two-party trade, right? So these are some required steps which are required by Corda for a transaction to happen, but not necessarily that basically your flow would have the same steps. It would have these, but you might also want to insert one or two depending on your use case. So which would basically come somewhere in between here. So looking at this example, when you want to just do sort of a two-party trade where you're trying to update something on the ledger, what you would do is initially as node A, who is initiating this transaction, he will propose an update. Now this is just a proposal, which means he wants a particular update. So he will create the transaction that I talked about, and then he will check the update that he wants to do. He'll check it against the contract, and if everything goes fine, he will sign the transaction, giving it a go ahead. And that means that he cannot later on say that I haven't done this, because he has a signature on that. And then it goes to node B, who is the counterparty in this case. They'll do the same checks where they will check whether this particular transaction that I'm receiving is valid as per the rules. If it's contractually valid, then they can also go ahead and sign the transaction. And finally, once everything is signed, they finally send the transaction to the notary. A notary, if you don't know, is basically a component within Corda, which takes care of your double spending. It makes sure that there is no double spending happening within the entire network, right? So once they are satisfied with this double spending check, they can sign the transaction. And once you have the notary's transaction, the transaction is ready to be recorded on the ledgers of every individual participant. So all this happen behind the scenes. You don't really see that all these things are happening. You can obviously write certain checkpoints which will tell you what's happening, but you just trigger it, and then all these different steps will run at once. So you don't need any manual intervention in between here. All right, so that's about it from the slides part. Now let's move on to our hands-on part. And for that, let me bring up my IntelliJ. All right, cool. So what are we really doing today? What are we building? So we're building a simple application, which is called as a token. So we'll have a token issued on the ledger, and we'll have an issuer will be issuing it, and then we'll issue it to someone who would be the holder of the token. this is basically, we're just concentrating for this session on the issuance part. The transfer is something which you can do at your own time. And to help you with that, we have certain examples, which is more like an art kind of CorDapp, which shows you how to do an art transfer. Now you can use the same logic that is being used there to do the token transfer as well. But for this one, we'll just concentrate on the issue and make sure that we understand how the issuance is done. Once we do that, I think it will be pretty easier for you to understand how the transfer will also be done. All right. So what we have here is this basically is the basic structure that you would get whenever you want to write your CorDapp. So you would have two main components that you would build. This is your token state, which is the state that you would build, and then we have the contract, right? So, and then finally the flows. There are two flows, but yeah, we'll talk about why we have an initiator and then a responder. But for now, let's just move on and concentrate on the states. Before that, we also have some test cases written over here, so that we know whatever we are writing is actually right. So later on, we don't really face any problem. So as we write our states, or the contract or the flows or each of this component, as we write them, we'll just go ahead and test them with our test cases so that we are sure that whatever we are doing is perfectly fine. All right. Is there a GitHub link? Yes, we have. Peter, would you mind just pasting it on the chat, please?
Yes, yes.
All right, so we have a question which says, are we using Corda 4.8 or Corda 5? So this is basically using Corda 4.x or 4. Not exactly 4.8, but maybe a previous version, but that's fine. We are not using any of the features from the latest version. It's not Corda 5 for that matter, because obviously Corda 5 is just on the developer preview and we don't have a global level or a GA done yet. So yeah. This is Corda 4.8. This is what you will use for your real deployment. But yeah, as and when we move across with Corda 5, we'll have more sessions which will more focus on Corda 5 going forward. All right. So yeah, coming back to our token state. So what really we want to do is with the state is, as I said, a state is something that you would represent on the ledger. So the token state that I would write is something that will go into the ledger. Now, if you think of it, what exactly do you want to have in your state? Just keeping it bare minimum so that we don't spend too much time on this. A state will obviously have an issuer, someone who would be issuing it, right? And then it would have a owner or a holder. The person would be holding the tokens in their account. And then just to make sure that how much token you're holding, you would have something like an amount, right? So let's do that. States are pretty simple. It's just like a normal Pojo class. Now, when I say you want to have an issuer and owner, right? So what exactly is an issuer? An issuer is basically, or the owner for that matter, both these people are basically identities on the Corda node or on the Corda network. These are like nodes on the Corda. So they are real identities which will be represented in the code. And how do we do that? We use something called as a party class from the Corda API. So whenever you want to represent an identity, you use this particular class called as party. And this party class, if you go or dig deeper into it, what you would have is your public key, your Corda 500 name, which is basically a naming format that we use. And then you have your public key and all those sort of things which they will be using for like signing the transactions and all. Okay. Yeah. Yeah, so coming back, the issuer is of type party. Similarly, our owner would also be a party, since this is also someone that would be an identity on the node, right? So will be an issuer is the guy who will be issuing it. The owner is the one who would be holding it. Now, the final thing that we need is an amount. This will represent how much token someone is holding. So that's pretty much all of it. I will not add more things for more complexity. Let's make it simple. And finally, just like any normal Java class, you need a constructor and you need getters. Remember, we don't really need setters because obviously there's going to be, since this is the state, it would be stored on the ledger and it's going to be immutable. So no point having setters. So finally, in order for Corda to understand that this is a state, we have to implement a particular interface, which is called as the contract state. What that would mean is you would have to have this particular method, which is called as get participants. What it really does is it basically gives you an opportunity to say who should know about this particular state. Now, if you have done our previous sessions, well, basically Corda is not like we don't use something like a broadcast where information is available to every node in the network. It's more of a point-to-point communication. So this token will only be known to the person who are involved in this any particular transaction involved in that token. So who are the people who would be involved in this token, irrespective of basically how many people are there in the network. So those are just two people, right? The issuer and the owner. So we just need the issuer and the owner to be passed from our get participants method. What this means is Corda now knows who should be knowing this particular token. So whenever it's being recorded on the ledger, it needs to understand that, well, the issuer and the owner are these two people who should know about this. So these would be something that would be providing to it via the flow, and we'll know that we'll get to know how we will do that later on. All right, that pretty much sums up how you would write your state, right? That's pretty simple. Just your variables that you want to put in, everything that you want to represent on your state, all the facts that you want to represent, and then just pretty simple normal things like your constructor, your setters, and then finally a simple method to say who are the people who should know about it. Yeah, int. Well, obviously, yeah, it cannot handle decimals, but we'll go with whole numbers. You can have decimals in your real world example as well. But it's generally for something like that, we use something called as amount, which would have your precision and all those things. I'll not go into the complexities of that, since this is the very first one someone would be writing. So trying to make it as simple as possible. All right, so as I said, we have some test cases to run. So let's see if everything that we have done is perfectly fine or not. All right, so basically, this is a very simple test, just checking for the constructors, getters, and setters, all those things. But the test will get a little bit more complex as we go ahead with our contracts and flows. But one thing that you might notice is the test identity. You might say, where did this come from? Well, this is a part of the testing framework that we have. It's called the test DSL. This is something that you would use to generate test identities for your test cases, basically. Yeah. All right, so I don't know if you noticed, but the test has completely passed. So we are good with our state. And then we can move on to our contract. If you look at the state, there is this particular line here which says belongs to contract, and it has been commented out, well, because contract wasn't written by then. So I'll uncomment this. Well, what this would say is it would tag your state to a contract. So basically it would say that this particular state, called as token state, is basically governed by the token contract. So whenever you want to update this particular token state, go to the token contract and see what rules are written. And if everything is fine, only then update. So that's what the contract validation part, which I talked about earlier. All right, so this is my contract. In order to make sure that we make this a contract, we'll just use this particular interface, and that would make sure that we are writing this as a contract. All right. Now what contract does is it gives you this particular method called the verify method. This is where all your verification takes place. Down here, we also have the command. The command is something which represents the intent of your transaction. So what that means is your token, you could do many things, like I talked about issuance, and you could also do like something like transfer. You could also burn it now, but there is just one contract. How do you write rules for different actions that you are performing, right? So we have commands to for that matter. So it would say what exactly is happening in this particular transaction. I only have issue here because we're not concerned with transfer or burn for that matter right now, but you could add them as and when you use, as and when you wish. And then you can fetch the type of command that we are passing in from the transaction, and then basically you can write your logic for the validation of that particular command or the action that has been taken. So let's see what are the different rules that you want to check. Obviously, the first thing that you want to do is for a normal, like or a more general kind of a command of a CorDapp, what you would do is basically you would check what command it is and then only go ahead with your validations. But since we have one single command for our use case or for our example here, let's just skip that part and move on to the real kind of validations that you want to put in. Again, I'm going to put very simple validations for the sake of understanding and for the sake of making it easy. So first thing is it's an issuance. So what exactly we're doing is we're issuing a particular token, which means at this point of time, we should not have any input. That's because you would have an input only when you are updating something. So unless something is available on the ledger, you can't pull it out and use it as an input. If you're doing that, you're basically consuming something else, which is not what we want. So that's why we would fetch our transaction, which is passed in from the parameter, and then see what we have for the inputs. So you see there's a list of inputs which we get from the get input states. And if I say, look at the size, then basically I would say that, well, if it's not equal to 0, that means we have a problem. It has some input. So I need to throw out an exception from here. 0 inputs expected. Well, what this really means is for whenever your verify method is executed without any error, which we basically understand that your transaction has gone through. So there is no issue with your transaction. So every time you do a test or you check for a validation in your verify method, you have to check for negative cases and then you have to throw exceptions. And exactly it's the illegal argument exception which we throw, and obviously you can put in a message which will let you know what exactly is going wrong. This illegal argument exception is caught by the framework, and they'll let you know that, well, this thing has gone wrong. So yeah, make sure you have those negative cases in here. Now the next thing we can do a similar kind of thing with our output as well. We are expecting one single output. We don't want someone to issue something else as well while we are trying to just issue a particular token, right? Let's say someone is issuing a house or a vehicle with this transaction. We need to make sure that's not happening. So this time, get output states, and the size for this should be 1, right? If it's not 1, then there's an issue. So we say 1 output expected. And then we also want to make sure there is one command. So this will also be pretty simple. All right. So those are things from the shape of our transaction, things like what are the size of different things and all. Let's move on and look at something like the content of a transaction, what exactly we are getting within this particular state. So now with that, we know that there is one input state, but what exactly is it, right? Is it a token state? So let's check that. Or there is one output state. There is no input, obviously. So we have one output state. So let's see, get output. Is it actually a token state? So if it's not, then that's not what we wanted. Say token state expected. What next? What exactly is the command that we're expecting? It's the issue command. So we'll go with the same checks. Now with commands, we have two things within the command. One is the type of command itself, which we get by the value. And others is the command is also accompanied by the list of signers, which would represent who should sign in this particular transaction. So for us, we are interested in the type. So we say get value, and this should be issue. If that's not, then basically issue. All right. So one last thing that I want to check is the amount that we're receiving is actually positive. We don't want to issue tokens that have a negative amount. That wouldn't make any sense. Or even tokens that have zero amount would be worthless, right? So transaction dot get output. We have to do a little bit of typecasting here, because what we get is the base type, which is your token contract state. Now I can access the amount from here. And if it's not positive, then we again need to throw an exception, which is your legal argument exception with a message, say positive amount required. All right. Finally, we need to check who are the signers of this transaction. So obviously the issuer must sign. So we'll see if the transaction has the issuer's signature. Now, do we do that? We talked about the command, which has signatures, right? So we can get all the signatures from there. And if you can see, the signatures are basically a list of public keys. So this should contain the public key of our issuer. So I say contains. Where do I get the issuer from? Well, obviously it's in the state. So I take the token state and say get issuer and get the owning key. Remember, we need to put the not clause. If that's not happening, then the issuer signature is missing, which is not what we expected. All right. That's pretty much it. That brings us to the end of the contract. So these are all the rules, which like simple rules. Obviously, for more advanced use case, you would have more different rules that would make more sense. But obviously, for this particular example of ours, this much of rules should work out. All right, so let's try to run the contract and see how it's going. While it runs, this is a bit of a more involved with the contracts that we see. We still have the test identity, which is basically representing your identities for your unit tests. And then these are the blocks of code that we have for each of the tests, right? So what you see is two blocks of transaction. Now, this is again our contract DSL in the that you can see in the picture here. So what it's doing is we're using the test DSL to create transactions, right? So for a contract to work, you need to have transactions. So this transaction block is actually creating a transaction, and it's putting in inputs, outputs in there. Now you might say, why two transactions, right? That's because we want to test different variations. One is when we are expecting one of them to fail and the other we're expecting to pass, right? So that's where if you look at this particular test case, what it's doing is it's checking if the transaction has 0 inputs or not. Now this one has an input, which means this transaction will fail. And then this one doesn't have an input, which means this transaction will pass. So that's what we're doing. We are checking for different cases, and you would see more cases as you go forward in the test case. For example, this one, you would see like 1, 2, 3, 4 different cases being used. So yeah, that's what is happening. All these transactions or test cases that we have here are a combination of different transactions, and some of them are passing and some of them are failing. If the one that should pass does pass and the one that should fail does fail, only then we say that the test case has passed. As you can see, all of our test cases have passed, and then you might have noticed there are some exceptions which we encountered. Now, don't worry about that. It's basically, like I said, we are expecting some of the transactions to fail, and that's exactly why you see these exceptions. These are for cases that our transactions have failed, but that's all right. Everything is fine here. So the contract is perfectly done. We have the state, we have the contract. Now, finally, what we are left out with is the flow. Now, flow, if you see, most of it is already written. And why is that? That's because this is more or less template code. There are a few things that we have to add to this, but for most of your flows that you would write, these are like mandatory steps that you would follow. So that's why we have already written them. Don't worry, I'll go through each one of them and say what exactly it's doing, but it's pretty easy to understand. It might look like a lot, but yeah, it's not much happening here. So first thing, why do we have two of them? Why do we have an initiator and why do we have a responder? Well, flows are supposed to run between different nodes, like we already said. So this transaction that we will create within this flow, or the issuance transaction, this transaction has to be taken from the issuer, and it has to be taken to the owner or the holder, and then they have to do stuff with this transaction, right? They have to like record it on the ledger. They have to check if the transaction is valid or not. Now, that means that each of these will have to have a particular code written at their end, right? So the initiator part is at the initiator end. So this flow will be running at the initiator node, or the issuer in this case, right? And the responder is basically running at the other end, which is the holder in this particular case, or the owner in this case, right? Now you can see that we have two variables here, owner and amount. You might ask why we don't have an issuer, and that's because anyone who is running this particular flow using the node, they by default becomes an issuer, right? So you have, if I am running this issue flow, which means that I am trying to issue it, so I am the issuer. I just need who the owner is and what the amount is, right? So that I can pass as part of these variables. So that is what is accepted in your constructor as well, right? Now coming down, your actual flow really starts from the call methods. When you trigger a flow, the control really comes here. And first thing that we do for our flow, this particular flow, exactly what we're doing is we're creating a transaction which will issue a particular token. Now, what do we need for a transaction, right? The first thing we need is a notary, which will be used to notarize your transaction, right? So we get hold of the notary, and how do we do that? We basically use something called as the service hub. This is something which is available to the flow, and it exposes, or it gives you access to different node services. One of them is your network map cache, which is basically a directory of all the nodes available in your network. And from there, you can fetch your notary. So once we have the notary, you want your own identity, because you need to pass it to the state or the token that you're creating, right? So you get that using this particular API method called as the get our identity. That gives you the identity of the node wherever it is running, right? So next step is we create our token, or the which basically becomes your output state as well, right? So what the token has the issuer, which we get here, and the owner and the amount are passed as part of the parameter. So that's pretty much it. That's our token state. Now you need to build a transaction, and to make it easier for you, we have something called as the transaction builder. And how do we build this transaction? You create a new instance of it, you pass the notary to its parameter, and there's other way as well. You can say set notary, that will also do, but yeah, we are using the constructor here. And then you can pass the output state by using add output state. And what is the output? Is the token state. There's also add input state in case you have an input, but obviously this transaction doesn't have an input, but it does have a command. So I'll say add command. What exactly is the command? The command is the issue command. And remember, the command has two things. One is the type itself, and the other is basically your keys, right? So arrays dot as list. So the key of the signer, issuer must sign. That's what we know. And we're also putting the owner as the signer here, just so that we demonstrate how you would really collect the signature from the owner, right? Though it's not a required thing in your contract, but it doesn't hurt to put it there. Right, so that's how you build your transaction. Once this transaction has been built, we follow certain more steps like we have discussed in our flow slide. So those are, you need to validate your transaction, whether it's valid as per the contract. And to do that, you call this particular method called as verify, and that will do the job for you. And once you're done with that, you can sign the transaction. So for that, you use this sign initial transaction method, and that will give you a signed transaction. So your transaction is now signed by your own keys. And finally, you're ready to send this transaction to your counterparty so that they can sign it and send it back to you. And to send it to your counterparty, you just call the collect signature flow. Now what we do is we establish a session with our counterparty, its owner in this case. Now, if there are multiple counterparties, you would basically create a list of sessions and then pass it over here. And what this collect signature flow will do is it will basically go to each and every counterparties and get their signatures and send it back to you as a fully signed signature. Now, when we do this, this obviously needs to go to the counterparty, right? So they have to capture that and put their signature as well. So that's what happens in your responder flow. So this is your responder. As you can see, we have a signed transaction flow here. So as and when your collect signature is called, the flow comes down over here, and the signed transaction flow is triggered at the responder end. And what that will do is it will take care of validating your contract, and then if things are well, then it will also sign your transaction. And there's also this check transaction that you could see here within the signed transaction flow. Well, that gives you an opportunity to do any additional checks that are not part of your contract. So things like we have a check called the amount must be positive in your contract right now, but say this particular counterparty, he doesn't want anything. He doesn't want just zero, right? He says, I don't accept anything below 1,000. So if there is some that is a requirement for this guy, then he can put it as part of these additional checks here. That's not part of the contract, but yeah, it would still be checked if he has put it here. So this is an individual check. It won't be checked globally, but just for the guy who has written it over here. Right, that's pretty much from the responder part. And once that has happened, the signed transaction will be received at the initiator's end. And finally, now to notarize it and record it on every individual counterparty, what it has to do is call the finality flow and obviously pass the sessions required, just like we did in the collect signatures. So everyone who needs to record this, so their sessions have to be passed. And the finality flow will basically take care of notarizing it. It will send it to the notary and then get their signature. And once that has happened, it will also make sure that this transaction is actually broadcasted or basically sent to everyone who is involved in the transaction, not really broadcasted to the entire network actually, but only to the people who are involved in this particular transaction. So for our case, it's just the issuer and the owner. All right, so that's about the flow. So let's see if it's working. We can also try to run our test case for the flow. All right. Okay, so is it possible for a participant in a Corda network only has a CorDapp with a responder flow? It's possible, but generally that won't happen because the roles are sort of like if I have a CorDapp, I am not sure if I'll only respond to it. I might also initiate a transaction with someone else, right? So generally, whenever you deploy a CorDapp, most of the time will have both the flows, and one of them will be used for a particular transaction. But yeah, it's possible to just have the responder as well. Okay, so as you can see, there were a lot of things happening as we run the flow test here. That's because obviously the flow needs nodes, and it really needs an entire network. So what's happening is a mock network is getting created in the background. So you can see that is happening in your setup part. We're creating a mock network, we're creating mock nodes, and then we're running this network. Once that is done, your flows are then being triggered. So yeah, all of them has passed. So our flow is perfectly fine. So with that, our simple CorDapp is ready. We can actually issue our token easily now. Before we do that, obviously we have to build our CorDapp, and we have to basically generate the artifacts, right? So how do we do that? There is something called as the build.gradle, right? It's a Gradle file which defines a particular task called as a deploy nodes task. Remember in the when we started this session, I said we'll be deploying this onto a test network. And this is how we create a test network here. What we do is we don't really create an entire live network ready to go. It is more of a development network which you can use for testing purposes. So what we do is we create certain node blocks, and this will define our nodes for this particular network that we are building. We have 4 nodes. One is obviously the notary. There is a party A, party B, and parties. 3 parties and a notary. And there are different other parameters to it, like what's the port at which it will communicate, what are the RPC settings, what are the users, and all these things, which will take care of different aspects of your node here, right? So in order to create all these artifacts for all these nodes, we have to run this particular method or the Gradle task. So let's go to our terminal and say, yeah. So as we do that, we will be getting a build folder, and within that we'll have these nodes. All right. So within this nodes directory, you have all the nodes that we have defined over here. That is party A, party B, and party C. And within that, you would be getting certain files. So they're getting created. It's not done yet. You'll get different files in terms of what will be needed for the node for functioning. This might take just another minute for it to generate all the artifacts. We'll wait for that. All right, perfect. So the task has completed successfully. Now we can go into one of these nodes and see what it has actually generated for us. So this is a folder called additional node info. Well, this is more likely your network map cache, right? That we use to fetch different identities. So this is where it all gets stored. And then these are the node certificate. Well, obviously dummy certificates. The CorDapp, which we have just written, has been copied over there. Different drivers. So it's not very useful at this point of time, but what we have is a Jolokia driver that's for GMX matrices, which you might want to fetch from your node to make sure that you understand how it's performing. But other uses that this might have is if you want something like enterprise DB, but open source just supports your, so by default, it has this the H2DB. It does support something like your SQL your Postgres and other databases. But yeah, if you are using that, you would need to use the drivers over here. Then logs, which is pretty self-explanatory. Just the logs for whenever it runs. Corda.jar is your platform, so that's the real thing. This is exactly what is running as your node. So you have something called as the network parameters. This is more or less likely your global settings or some certain global parameters that is common for the entire network that we are building. So things like which version of Corda you are running, what's the minimum version that you would support, and few other things. Node.conf is just a configuration file which has the node's name, the addresses, and the users and stuff. So this is basically what has been just copied from our node block here. So any configurations that you want to tweak can be done in the node.conf file. And obviously, finally, we have the persistence files. These are the part of the H2 database. Right, so that's what are the artifacts for your nodes. Now, how do we run this network now? In order to help you with that, these are just Java files, right? So you Corda.jar are just Java files. So you can just say Java jar and Corda.jar. That will run your node. But there's a simple way of doing that. It's called as if you see there's a run nodes file there, which is just a script which will help you run all the nodes at once. So let's just do that. Okay. Let me do something else. Now, this should be easier to understand. So instead of running it on an external terminal, what I've done is I've run it within the IDEA terminals itself. So you have the notary, you have party A, you have party B, and you also have party C. So we'll wait for them to get started. Might just take a minute or so. Almost there. Notary, and then we have party A. All right, so there you go. So your notary is up, and so is party A. So is party B and C as well. All right, so when when your node starts, it basically gives you this terminal where you could go ahead and type certain commands. So let's try that, something like a help. So this gives you all the different commands that are available. You can go through them at your own time, but I'll use some of the commands, or I'll let you know about some of the commands which will be most frequently used. So one of those things is something like you would really very frequently used is check what are the flows that are installed on your node. So you say flow list, that'll give you a list of all the flows that are installed. So you can see 5 flows, obviously, but that's not what we have written. We have just written the token issue flow. And obviously there was an art flow, which was already there. Now, these are system flows that are required for upgrades and stuff, nothing to be concerned of at this point of time. So we are currently just dealing with the token issue flow, right? Let's see how do we trigger this flow. So for that, we have something called as a flow start. And then you just say the name of the flow. And if you hit enter, it will throw you this error, which says what are the constructor parameters that you need to pass. Let's do that. The owner, since we are issuing this particular token from party A, that means party A becomes the owner. So let's issue it to party B, say. And then the amount that we want to issue says 100. Right? Then hit enter. What that will do is it will run our transaction or the flow that we have written. And once it has completed successfully, you can see that it has given you a transaction ID. And now to verify whether it has actually issued something or not, we can query the vault. The vault is your node database, just for that, you know. So in order to query the vault, use something called as a run command, and the run command will use run vault query with a particular parameter called contract state type. This is where we put the type of the state that we are trying to fetch. So for that, for us, it's bootcamp.token state. And you can see this is the state that we have just created. Issuer is party A, the owner is party B, and then the amount that we have created is 100. And there are a few other data, as in who's the notary, what's the contract, and something around constraints. We'll not get into that. There is a transaction has, and more metadata, as in what's the time at which it's recorded, whether it's consumed or not consumed, and a few other information. Right. Since I have created this and issued it to party B, I should also be able to see this particular state at party B. Let's go there. Yeah, there you go. So this is exactly the same version or the same exact copy of what you would have issued and would have seen in party A's node. But since party C was not involved, he wouldn't have anything in his ledger. Yeah, that's how you build your CorDapp. Perfect. Okay, so that brings us to an end of this particular coding session. I'll just stop sharing. Perfect. Do we have any questions left? I think we do have 5 minutes, so we can spare that time to take any questions. All right, I think most of them are already answered. Cool. So if you don't have any more questions, so well, that's pretty much from my side on this particular session today. Thank you everyone for joining us. I hope you liked this, and I have to see you on the next session. You can also go ahead and try out this particular example or the demo that we showed. I think we have already shared that with in the chat. And yeah, feel free to join Slack, talk with us if you have any doubts and all. Yeah, and I'll see you in the next session. Thank you so much for joining once again.